In this session, we are going to look at what is modular arithmetic. Modular arithmetic is like integer arithmetic, but with two main difference. Modular arithmetic focuses on the remainder. It is an arithmetic for integers, but here we are focused on the remainder. And the next important thing is numbers wrap around after reaching a certain value. So beyond a certain value, the numbers again wrap around. We'll understand what this arithmetic is by taking the example of a 12-hour clock. So this is a 12-hour clock. You see here, this clock contains all integers that we agree upon. And the next thing is, if you take a look at the numbers, it starts from 1, 2, 3, 4, 5, 6. It goes on like that. After reaching 12, you can even say 12 as 0. So after reaching 12, the numbers wrap around. That is, again, it starts from 1, 2, 3. So in a 12-hour clock, after we reach 12, again we start from 1. So these are the two important things in modular arithmetic, and a 12-hour clock satisfies that. So let me take an example. Let's assume that now the time is 9 o'clock. If I tell you I'm going to meet you after 2 hours, what will be the time? If I'm going to meet you after 2 hours from now, what will be the time? So it is 1 plus 2. The time will be 11 o'clock. Let's forget AM and PM. Let's just talk about the time. Let's say it's 11 o'clock. So if I am meeting you after 2 hours, the time will be 11 o'clock. So how did you achieve that? It is nothing but 9 plus 2, that is equal to 11. Now let us take another scenario. The time is 9 o'clock. I want to meet you after 6 hours. Say if I want to meet you after 6 hours, what will be the time? So normally how we compute the time, okay, it's 9 o'clock now, and after 6 hours I'm going to meet you. So it should be 15. So the answer should be 15, but in a 12-hour clock, you can see there is no 15. So how will you find this? What is actually 6 here? It is 1, 2, 3, 4, 5, 6. So if I'm going to meet you after 6 hours from now, it should be 3 o'clock. But what is the actual result we are getting when we add 9 and 6? 15. But in a 12-hour clock, it is actually 3. So how you compute this is, we do a mod, we take 15 and then we do mod 12. So 12 here represents it's a 12-hour clock, and this mod operator, what it is used for, we all know that by programming, you divide 15 by 12. That is the meaning of this. So how many 12s you have? Just one 12. What is the remainder here? 3. So now we are getting the answer. So in a 12-hour clock, if I'm going to tell you that I will meet you after 6 hours, it means I'm going to meet you at 3 o'clock, and that is what we arrive at. Is that clear? Okay. So let me ask you another question. Let's say if I'm going to meet you after 8 hours, let's assume that time is 9 o'clock now. If I'm going to meet you after 8 hours, what is the time in the clock? So how will you compute that? It's simple. You know it's 9 plus 8 is equal to 17. But since it's modular arithmetic and numbers wrap around, so what we do is we take 17 mod 12. So what is 17 mod 12? 5. The remainder is 5. So we are focused on reminders. So it means I'm going to meet you at 5 o'clock. So please keep in mind these two things. Modular arithmetic is an arithmetic for integers, and here we are focused on the reminders. And in modular arithmetic, the numbers wrap around after reaching a certain value. Now I have an exercise for you. Can you find the answers for all these things? What is 18 mod 12? You divide 18 by 12. 12 into 1 is 12. The remainder is 6. What is 24 mod 12? So you divide 24 by 12. The remainder is 0. 12 into 2 is 24. Remainder is 0. What is 32 mod 12? 32 mod 12 is 12 into 2 is 24. Remainder is 8. What is 4 mod 12? So now comes this. How many 12s you have in a 4? Very silly question to ask. So it's 12 into 0, 0 times. So what is the remainder here? 4 mod 12 is nothing but 4. And what is 8 mod 12? It's nothing but 8 because 12 exists 0 times in 8. So we are worried only when we exceed the number. When we exceed 12, what is the remainder? If anything that is lesser than 12, the mod will be just the number. And whatever example we have taken here is with respect to a 12-hour clock. The number here can be anything. This we call that to be the modulus. The number here can be anything. For instance, if I talk about 90 mod 30. So now we are going to divide 90 by 30 and we are going to get the remainder. So that will be 0. So if it is going to be anything less than 30, say if it is 5 mod 30, since this is lesser than 30, the remainder will be just 5. Please keep this in mind. And now we are going to see a very important concept called congruence. We'll be talking for the next 10 to 15 minutes on congruence. Before even going into congruence, let's take a look at our 12-hour clock again. And you see here the numbers after reaching 12, again it starts from 1. It's in a circular fashion. Suppose after 12, if you want to continue writing the numbers, how will I write? It's 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So what we understand from this is using this 12-hour clock format, we understand 15 is equal to 3. If I say I'm going to meet you at 15, it means I'm going to meet you at 3. So we can very well say 16 is equivalent to 4 with respect to a 12-hour clock. So please keep this in mind. When I say 17 is equivalent to 5, I'm saying that with respect to a 12-hour clock. So very well I can say if suppose the time is 9 and I'm going to meet you after 6 hours, it means I'm meeting at 15 or the time will be 3. Both of them is the same. So how we can write this is 15 is congruent to 3 with respect to mod 12. What does that mean? It means something like this. 15 is equivalent to 3 with respect to mod 12. Only with respect to a 12-hour clock, we can say 15 is equivalent to 3. Likewise, we can say 16 is congruent to 4 with respect to mod 12. Okay, so this symbol is called congruence. Are you all clear with this? If you are very clear with this, you can very well understand the concepts that are going to come later on. So now let us see the definition of congruence. We say A is congruent to B mod n if n divides A minus B. Very simple property. We'll take our example from the previous slide. 15 we say is congruent to 3 mod 12. We say 15 and 3 means the same with respect to mod 12, right? And they say this congruent means n divides a minus b. So they say 12 should divide a minus b. That is nothing but 12 should divide 15 minus 3. So 12 will divide 12. So that is what is the meaning. So what is this? If a is congruent to b mod n, then n will divide a minus b. We have proved that. Okay. So whenever you have something like this, a is congruent to b mod n, it means n divides a minus b. Now let us look at the properties of congruence one by one. We'll understand them with samples and proofs. Let's start by the very first property. It says A is congruent to R mod n, where R is the remainder we get by dividing A by n. Say let us consider A to be 15 and n to be 12. When I divide A by n, 15 by 12, what I'm going to get, the remainder is 3. So this is R, this is A, and this is N. That's what they are saying. A is congruent to R mod N, that is nothing but 15 is congruent to 3 mod 12. So this is a property, when you divide A by N, the remainder you get, that will be congruent to A. Am I clear? Okay. Very simple. You can just take this simple example you understood. 15 is congruent to 3 mod 12, and we'll be able to understand all the properties. Now let us take a look at this property. A is congruent to A mod n. This is called reflexivity property of congruence. What is A is congruent to A mod n? What is the proof? See, what is A congruent to A mod n means? It means n should divide A minus B. Here A and B are the same, so it should be A minus A, and n divides 0. According to the property of divisors, we know that any integer will divide 0. So this is already proved. So we have proved that A will be congruent to A mod n. That is a proof for reflexivity. We all agree n divides 0, that is nothing but 0 by n is equal to 0. So we have proved that n divides A minus A. So this is true. The next property that we have to look at is, it's a property called symmetry, and it is A is congruent to B mod n, and this implies B is congruent to A mod n. This is the property of symmetry for congruence. Okay, to understand this or to prove this, we have to understand the property of a divisor. For instance, we say n divides A and same n divides B, then this implies n will divide A plus B. Let's substitute some numbers here. For instance, if n is 5, 5 divides 20, yeah, and 5 divides 10. If this is true, then this also is true. 5 will divide 20 plus 10, right? So 5 will divide 30. So this is the simplest, this is a simple property of a divisor. We're going to use this property to prove this. So when you say A is congruent to B mod n, what does that mean? N divides A minus B, according to the definition of congruence. And when I say B is congruent to A mod n, what does that mean? It means N divides B minus A. So we have n dividing A minus B and n dividing B minus A. This means, according to this property we have seen here, n divides A minus B plus B minus A. So this is actually n divides 0. So n divides 0 is true because 0 by n is 0. So this is again according to the property of divisors. When n is an integer, it divides 0. So we have proved. So since we have proved this, we can always say when A is congruent to B mod n, B is also congruent to A mod n. The next property is the transitivity property. It says A is congruent to B mod n, and when B is congruent to C mod n, this implies A is congruent to C mod n. We can use the same property of the divisors to prove this one too. Let's go and take a look at that. So we have A is congruent to B mod n. That means n divides A minus B. And we say B is congruent to C mod n. That means n divides B minus C. Now what we have to prove is A is congruent to C mod n. So by the property of the divisors, so by the property of the divisor which we have seen, when n divides A minus B and n divides B minus C, n will also divide A minus B plus B minus C. So what is the final result here? So this will cancel out, and what we are going to be left with, n divides A minus C. So when you have n dividing A minus C, what does that mean? A is congruent to C mod n. So that's what we have to prove. We have proved this. This is the property of transitivity. So we have seen the proofs for all these properties of congruence. Now let's go to the next property, addition by a constant. So what it says is if A is congruent to B mod n and C is a non-zero integer, then this is also true. A plus C is congruent to B plus C mod n. So let's take our example. Say 15 is congruent to 3 mod 12. This is what we have found out from our 12-hour clock. So now let us take C to be some integer that is not equal to 0. So if C is 2, this is also true. 15 plus 2 is congruent to 3 plus 2 mod 12. So what is 15 plus 2? 17 is congruent to what is 3 plus 2? 5 mod 12. So is this true? Yes, because 12 divides 17 minus 5. So 12 divides 12. So this is true. When you have n dividing A minus B, then we can always say 17 is congruent to 5 mod 12. So we have proved that. The same thing applies for subtraction too. Say if you take C to be 2, we have 15 minus 2 is congruent to 3 minus 2 mod 12. So what is 15 minus 2? It's 13 is congruent to 1 mod 12. We can also directly verify it. This is nothing but what? 13 mod 12 is equal to 1 mod 12. 13 mod 12, the remainder is 1, that is equal to 1 mod 12 is 1. So this is also true. So when you add an integer constant on both sides, that will also hold. So A plus C congruent to B plus C mod n. Likewise, A minus C is congruent to, this is actually B minus C mod n. That's a typo there. But this is not valid. You cannot add a constant to n2. A plus C is not congruent to, we can say A plus C is not congruent to B plus C mod n plus C. So these are some of the properties of congruence. Can I go further? Let me go to the next slide. It's called multiplication by a constant. So let's look at this property. If A is congruent to B mod n, if A is congruent to B mod n and C is not equal to 0, C is an integer, then this is true. AC is congruent to BC mod n. We can verify this. We'll take our famous example. 15 is congruent to 3 mod 12, right? So let's assume C to be 2. Now what we can do is we can multiply C on both sides. So it's 15 into 2 is congruent to 3 into 2 mod 12. So what is 15 into 2? 30 is congruent to 6 mod 12. So you can very well verify it like this. 30 mod 12 is equal to 6 mod 12. So 30 mod 12 is 6. 6 mod 12 is 6. So this is true. The other way around to verify congruence is 12 should divide 30 minus 6. 12 should divide A minus B. So 12 divides 24. So again, we have proved that. So when this holds, this one also holds. Likewise, this is also true. We can take AC is congruent to BC mod NC. Say we can also multiply that constant with the modulus n, and even that holds. So let's go and try this one out. Okay, let's go and verify this. Let's take C to be 2. So it is the initial thing is 15 is congruent to 3 mod 12. So we'll multiply 2 on both sides. So it is 30 is congruent to 6 mod. What is 12 into 2? We'll multiply 2 here too. It's 24. So it is equivalent, right? 30 mod 24 is equivalent to 6 mod 24. So what is 30 mod 24? Reminder is 6. 6 mod 24 is 6. Another way to prove this is 24 should divide 30 minus 6. So 24 divides 24. So we have proved. I hope you all have understood the concept on congruence and the properties on congruence.